Hi everyone and welcome back to another episode of sound design for video games. Today we're going to be talking about how we mix our audio inside of Unreal Engine, and we're also going to be going over the concept of concurrency, which is where we manage the overall load that our audio is going to have on a system. So we're going to be using something called sound class mixes. A sound class mix is essentially where we go over the overall balance of an entire mix. And this is then based on sound classes, which are essentially groups of a certain type of sound. So a sound class might be something like for voiceover. So that is a place where you will put anything that's the voiceover that will go into a sound class, and all of those will be grouped together. Then we're going to go over something called concurrency settings or sound concurrency, which is where we can set rules, for instance, how many of a given sound is allowed to play at a given time. And what are the rules which will allow us to turn certain sounds off if it exceeds that limit. So that's essentially what we're going to be doing today. Now in this series, what we're going to be doing is we're going to be going between this sort of presentation style and also Unreal Engine. So when I feel like, oh, do you know what, we need to go through this in a little bit more detail, we'll go inside of Unreal Engine and I'll actually show you things inside of the engine. If I think I can just be really efficient with your time, we'll just stick with the presentation. So how do we make a sound class and a sound class mix? Well, it's very simple. You simply right click in your content drawer, and then you're going to go to audio and then classes, or you can literally just type in sound class and sound class mix and it will come up for you. Now when you open up a sound class mix, it's going to look something like this. So what you can see is here in our sound class mix, we have these sound classes, and we have sound classes like sc_master. So this is my sound class, which I've created, where essentially every single sound in the game is being routed into this. We have one called sc_vehicle, and we have more than that underneath. So here is my sound class actually opened up. So you can see it's kind of like it starts off on the right here and all the audio signal flows to the left. So here I have the engine, crash, surface audio and tire screech. All these are sounds that are made by a vehicle. Therefore they all flow into a sound class called vehicle. So they're all grouped together. Then I have a checkpoint sound that's grouped into one called sound effects. So anything that's a sound effect can be grouped into here. And I have one called ambience. So I have wind here and I have spatialization. So all these are sound classes which are being grouped together and eventually all meeting under the sound class _master. So essentially these are sound classes, very useful for grouping and sort of visualizing the flow of your audio. Now when you want to set a sound class mix, so say for instance, we want to use this sound mix, which is holding all of these sound classes. So what you would do is you would go into the map blueprints, and you're going to get an event begin play, and that's where you can use the node set base sound mix. And you can see I've actually selected in this little drop down menu sound mix. Right, now let's go into the engine and show this in just a little bit more detail. Now inside of Unreal Engine, here is my sound class master, which I've opened up, and you can see it's all sort of branching off like this. And here is my sound mix. One point that I wanted to make is that, let's say if I change the volume of this sound class _vehicle to 0.5 from 0.7. So now I'm saying I want this to be 50% of the volume as it flows into the master. Now let's say I then go into sound mix and I go to this vehicle and I set this to 2. What's essentially happening here, just to help you visualize how these volume adjustments are being made, it's happening here first. So I'm saying here, I want this to be half the volume, and then it's flowing into this sound mix because it's here. And then I'm saying, then I want to double it. So what's happened is I've set it to 0.5 and it's taking that 50% value and doubling it back to 1. So all we've done is we went round in a circle and ended up with this at 1 essentially. So I'll put that back. I was just sort of making that point just to sort of make you aware of how the signal flows. The other thing I want to show you is the fact that you can create sound classes very, very easily. So for instance, you can create a sound class just by dragging off here and giving this a name. And essentially the sound class will automatically appear in the content drawer, essentially where those sound classes usually are. So it doesn't even ask you where to put them. It'll usually just put them in the same folder where these are, essentially where these sound classes are. Obviously, as we've already discussed, you can create a sound class from inside of here, go to audio, believe it's classes. And you can also create a sound class inside of the actual sound class mix. So if I look at this and I do go to the drop down, you can see create new assets, sound class. So there's all the ways that we can create those sound classes. Now allow me to show you all the different ways you can add a sound class to your sounds. So inside of a meta sound, you will go over here to class, and you can see I've set this one to sc_engine because this is my car engine meta sound. This is what's playing all of this car engine sound. Inside of a sound queue, I've just made one dead quick here. You have class over here, and here's all the sound classes. So if you have a sound queue, this is how you would add it to a sound class. And you can also do it inside of a blueprint via a sound class override. So say for instance, right here, I have my car engine meta sound loaded into this blueprint so that it will emit the car engine from the point of view of this car, basically. Now I might say if a sound is present in a certain blueprint, I want to override its sound class. So here you can set this, and let's say I want to just set this straight to vehicle, or I want to just send it straight to the master. I can override the sound class of the actual sound inside of here. So obviously there's some specific circumstances that you may want to do that. To demonstrate concurrency, I've set up this little demo here where from the blue ball is emitting a low tone. From the green ball is emitting a mid tone, and then from the red ball we're emitting a high tone. And then in the concurrency settings of all these sounds that are emitting from these balls, we're basically saying we're only going to allow one sound to emit at a given time. So there are 3 sounds that are trying to emit, so now we have to then give Unreal Engine the rules of, well, what sounds should we stop from emitting in our level? And you can see I've writ stop farthest, then oldest. So by this rule, what it essentially means is the red and the green ball should not be heard, only the blue ball should be heard. So that low tone is what we should hear. So first thing you have to do is create a sound concurrency. You are going to go to the content drawer, audio, and then mix, and you'll find the sound concurrency there. When you open up, it's going to look something like this here. So you can see here, we can tell max count 1. You can set that to any number. Obviously in real world examples, when you're making the game, it's going to be a lot higher than 1. In this case, we're going to force it to essentially work, which is why I've set it so low. So we set the max count to 1. You've got different options here, but the main one I'm focusing on is the resolution rule. So what happens when we go above 1? We're going to say stop farthest, then oldest. And there's plenty of other options in this drop down. So if you go through them and you can pick the one that sort of makes the most sense to you for a given situation. The next thing we have is the actual concurrency settings and how we set them. So here, what I have, it's actually inside of a blueprint. So inside of the balls blueprint where the sounds are emitting, we are highlighting the audio components, going to the details panel on the right. And you can see if you type in concurrency settings will come up, and you can add an index. And this is where I've added this concurrency setting here, this sound concurrency. I've called it scon_distance, and you can see here loaded in is scon_distance. And you can add these to many things. So for instance, you might add it to a sound cue, a meta sound, and as we've done here, we've added it to an actual audio components inside of a blueprint. So inside of Unreal Engine here, you can see where I've created my sound concurrency. This is it opened up where we have our rules. You can see as I open up this blueprint, which is of our little red ball here, you can see if I select the meta sound, which I have open, I can go over here And if I type in con, we have our option to add in a concurrency. You can also do it in the sound itself. So if I open up the meta sound and I go to source, if I just type in con in here, we have override concurrency, and we have this index where we can add our concurrency rules. You can also do it in a sound cue. So once again, I've already had it written in here, conc, and you can see override again, and you can add your concurrencies here. And you can also do it inside of footsteps. So for instance, audio. So this is an audio of footsteps, a sound wave of footsteps. So you can do it actually on individual sound waves. So you can see override concurrency, and you can add it here. So there's plenty of different places where you can add those concurrency rules. So we've added our sound concurrencies to each of these sounds, and they're all the same. They are this one, which is stating we only want one sound to sound, and stop farthest, then oldest. So those are the rules. So let's actually take a listen to each of these. So if I drag this one in, we should hear a low tone. If I get rid of that and I drag in the green, we should hear a mid tone. If I get rid of that and I drag in the red, we'll hear a high tone. So now that you are familiar with what each of these sound like, what should happen is we should be able to, say for instance, drag in the blue ball, drag in the green ball, have that a bit further away, and drag in the red ball, have this one, let's say here. So by our rules, what should happen is we should hear only the low tone, because that's the closest to the player. The ones which are furthest away should not play, because we said we only want to hear one of these sounds at a given moment. So the ones furthest away should play. Now if they're in exactly the same position, it won't go by that, it'll go by which one was the oldest. Whichever one was the oldest, those are the ones which won't play. So if I click play now, we should hear the low tone. And we do, the other ones don't play. If I move this blue ball back, and let's just make this green ball a little bit further back, just to help Unreal Engine out a bit, we should now hear the mid-tone. And we do. Now if I move this green ball back, we go all the way back here, we should now hear the high tone from the red ball. So that's all working perfectly well. One thing I do want to show you is a little quirk with Unreal Engine. So let's say we have them very closely together. So if I do this, you would think that it would say, well, the red and the green ball are furthest away, therefore we will only hear the blue ball. And yet that's not the case, as you just heard then. So I don't really know what's happening here. I think when they're very close, what's happening is they are assumed to basically be in the same location. Even though there are slight differences in distance, I think when they're this close, they're essentially being assumed to be in the same location. So it's fallen back on its second rule, which is then oldest. So I'm wondering how this works. Is it indexing them? I'm not entirely sure, because technically speaking, all these are starting on the event begin play. So they're all actually starting at the same time. So I'm not entirely sure how it's resolving that rule. So let's actually do a quick little experiment. So let's say it is indexing them based on when I place them in the level. So I'll place the green one first, the red one now, and then I'll place the blue one last. Now, the question I have is it indexing them based on when I play them? And that seems to be the case. So it seems to be the case that it's when you actually place them in. Let's do it differently. Let me place the red one, then the green one, and then the blue one. So by that rule, it should now be the blue one that plays. I suspect it might be the red one though. Yeah. So somehow this is being initialized in a way where the ones which are furthest away are essentially the ones which are the newest sounds. Therefore, the ones which are closer are the ones which are being cancelled out. So that's what it looks like is happening. Now, for the most part, that won't really matter, because if they're spread out like this, the concurrency setting, which I've chosen, will work fine, which you can see here. So yeah, I just thought I'd do a quick little live experiment with you and try and figure out that little quirk of the system. It's just something to be aware of. So to finish up, I just thought I would share with you some useful links. So this is a video called How to Mix Audio in Unreal Engine 4, and it's by the YouTube channel Valkyrie Sound. Now, he does a really great job of going through all the systems, and he does it in a much greater detail. What I've given you here is just a very simple overview to get you started, but if you want to really get to grips with it, I do suggest you go check out his video. It's really good. Also, if you would like some learning resources, the best place you can go is actually my website here. It's sotasound.co.uk. You can go to courses, and when you take these courses, what I'm going to start doing is I'm going to start actually leaving learning resources. So this will actually give you links to my actual presentation here, and this presentation has a load of different things where you can get all sorts of information and essentially use it as a reference guide. So for instance, let's say you open up the presentation, you might say, oh, I want to learn about dynamic footsteps. You can click on this, you can start learning about it. You say, okay, I've learned about that. I'll go back to contents. Oh, next thing, oh, let's learn about what we learned about today, mixing and concurrency. You can go in here and learn about mixing and concurrency. And you can quickly dart around, get references to different things you might want to learn. And that's kind of the way I'm trying to set this up now, to make it super convenient and really easy for anyone to learn a given thing in a very modular way. So anyway, I just thought I'd leave it there and let you know that you can go to the website and go and get those links from the courses section. So it'll be in one of these. It'll probably be a new one. This is an older course now, which I'm finishing up very soon. But there'll be a new sound design course, which is where you'll find the links to all those learning resources. So keep an eye out for that. Anyway, thank you very much for watching. I'll catch you next time.